Yeah, let's grab a couple from the book here. I'm gonna let you guys, unless you have if anybody has a specific trig sub they want to look at, we can look at it. Otherwise, I'll just kind of pick something at random out of the homework section. So let me know if you have a specific one you desperately want to look at. Yes.
I don't know which one it is specifically because I'm using WebAssembly.
Got you.
Do you want to look at it, or should I?
Here, hold on. Let me get this out of the way. Let me grab some paper. Did I bring any? Yes. Look at me go. And a pen. All right, so read it off to me.
Okay, so it's the definite integral between 2 and 3, and it's 1 over.
Is that fuzzy? There we go. 1 over.
X squared minus 1, and all of that is to the 3 over 2 power.
And that nothing else in there? Okay. All right, cool. So I warned you guys that trig sub will work even if it's not a radical or if it's more than just a 1/2 power. Yes? Thank you. So are you guys at a point where you're comfortable with looking at it, taking a second and figuring out what sub you should use? Sorry, there's some of you guys looking like. Alright. Either you just memorize the shit, or you kind of, hopefully what I was saying makes sense. You have to know your identities anyway. You have to know your identities anyway. So which identity is trig function squared minus 1?
Secant.
Secant. You guys with me? Has anybody ever heard of a memory dump?
Mm-hmm.
When you get a test, you immediately write on the test several things that you have to remember. You guys have never done this before?
I've done it.
Okay. Do never ever do that on another piece of paper because I don't know when it happened. If you do it on your test, I'll know you did it after I gave you the test. You guys with me? I've had teachers that outlawed memory dumps, and I'm like, you're just a weird person. Okay. You guys kind of with me? All right. So is everybody cool with this? This needs x equals secant theta. All right. All right. So if I let x equal secant theta, what do I get from that? What do you mean?
Whatever.
It would be secant theta and tangent theta.
So in a weird way, you were right, Dan. We do kind of produce a tangent. So just say that's what you meant. So now I've got everything I need to replace the stuff inside, yeah? The crappy thing about this problem is if x is secant theta and x is 2, that has a nice answer. If x is 3, that does not have a nice answer. I don't know if you see what I mean. Maybe not, okay. So, real quick. Is this a definite interval?
Yes.
Did we change the variable? These are what x is doing. What do I need to know?
What theta is
What theta is doing. So if I take a minute and I say, when x is 2, what's theta? Now, you know some values of trig functions. Or let me say it this way. You're supposed to know some values of trig functions. Yes? Does anyone know what cosine of 60 degrees is? Or cosine of pi over 3? 1/2. It's far away from where it likes it, so it's going to be small. The little turtle's going in a shell, 1/2. What does that have to do with this problem? Because what is secant theta?
1 over
1 over cosine theta. So if 2 is secant theta, then what's cosine theta? 1/2. And we just said that would make theta pi over 3. That would pull it farther away from the x-axis, so it's going to be small, because cosine likes x. You doing okay so far? Yeah? Okay. Do you guys see how I'm going to have trouble with the 3, the limit of 3? Not a lot. So when x is 3, what is theta? Well, can anyone tell me? Cosine theta is 1/3. That's not something we have memorized. So how do I solve for theta?
Take the inverse.
Inverse secant. I like, okay. So again, I especially do this, even if you're not gonna take Calc 3. I really don't care. Because part of what we have to do in Calc 2 is get used to changing limits. If you're going to take Calc 3, you're gonna do several levels up of basic changing limits. So it's good to get some practice now, before you start running into triple integrals and the limits are functions themselves, because that's what Calc 3 is gonna throw at you eventually. So now I can rewrite this integral, yes? I know what the new limits are. What are the new limits from what to what?
From 1/2 to,
No,
or pi over 3
pi over 3,
to
inverse secant of
inverse
3.
secant of 3.
What do I put inside here?
Secant squared plus or minus 1.
And what's dx?
Secant theta, tangent theta, d theta.
Yes. Thankfully, not a lot of you are doing this, but some of you guys are just forgetting the dx, so you're forgetting this piece, and whatever's left over, it gets weird. So dx is very important. You always have to have it, or else the integral doesn't make sense. Now, what is secant squared theta minus 1? The whole reason we chose it.
It's
Say it again. Tangent
Square.
squared. Okay, now. Can anyone help me simplify this?
well, 3/2 just means that it's something that's
Don't overthink it.
got a root and cubed, so then the two
Twos cancel, yeah. When I raise something with the power to a power, I multiply powers. So 2 times 3/2 is 3, so now on the bottom I have cubed, tangent cubed, right? I'm gonna go ahead and slap those up top. Secant theta, tangent theta, over tangent cubed theta.
Is that not cotangent?
Say again?
Over tangent, that's not cotangent.
It totally is, but I didn't do that yet. I'm not going to. I want to show you why. Well, let's see. Can't I kill one of the tangents?
Mhm.
Okay. Let's see if this gets us anywhere good. Now, what's kind of bad about that? If I try to let u equal tangent, what's du?
Secant squared, and it's not squared.
That is said correctly. Secant squared. Anybody have a suggestion on what we can do?
Can you change tangent back?
Split it into 1 over cosine.
Yes. Take it to sine and cosine.
Sine.
Sine and cosine are better related to each other. Yes. One is the other one's derivative directly. I need you to see this. If I let u equal tangent, I would need secant squared. I don't have it. So tangent and secant's derivatives suck. They're not nearly as nice. Sine and cosine, directly related to each other. Sometimes there's a negative. How much do we care about constants? We don't care about them. We do what we want. We can control them. So, but this sucks. Secant and tangent, they have to have perfect because their derivatives are not directly each other. So if you ever get to this point and you're like, no use subscribe, change it to sines and cosines. How do you do that shit?
Use trig identities.
Yeah. I mean, what's secant?
1 over cosine.
1 over cosine. And what's tangent? Yeah. Let me see if you guys are cool with this. So 1 over tangent squared would be 1 over sine squared over cosine squared would be cosine squared over sine squared. Is that cool? Times 1 over cosine would be cosine over sine squared. Do you see a u sub that'll work now? If you don't know what I just did, do it yourself. Rewrite it. Write out all the sines and cosines. Simplify. You'll get there. Do you see a u sub that'll work down? Cosine theta over sine squared theta. U equals sine. But do you see the motivation at that last step? Secant and tangent are not directly related to each other through derivatives. Secant is secant tangent, and tangent secant squared. But if I change them to sine and cosine, I have a much higher probability of a u sub working, because they are directly related to each other through a derivative. I don't know if you guys understand. So now, is that cool? I don't know, is that further than, does that make sense?
No, yeah, it made sense to me, I just kept getting the wrong answer.
Did you get there?
Yeah.
Oh, okay. Okay. Sometimes it could be a formatting problem with WebAssign,
Yeah.
which is one reason why I really hate online homework, and that's why I make it optional. Because it just, so, if you're really sure about the work after this, just hit that, ask your instructor, because then I can see if it's a formatting issue or what it is, yeah. Sometimes you have mismatched parentheses, and it's like, you're wrong. Sorry if you love online homework. It does suck, but if you love it, you got it. It'll work. It'll get you through. But it does suck. Sorry, somebody's got a little panda head, and it's like, I was taking it like a threat, like I found it, like a little panda head. What a weird message to send. Like when somebody wears a shirt that says, keep talking, I like watching the mouth move. I'm like, oh, okay. All right, guys, I'm sorry. So is everybody kind of cool with what just happened up there? Semi-decent? No? Let me help you guys out. I see faces out there. If I ever do something, the minute I do something and it doesn't make sense to you, it doesn't make sense to at least 5 other people. If none of the 6 of you speak up, I'll never know. Does that make sense? So, dear God, ask. Not a big deal. Right? Okay, I can't control yourself. Yes?
And then from there, you just use them.
Yeah. So again, on the secant and tangent, I couldn't use u sub. Because u as tangent I don't have what I need on top. But if I switch to cosine and sine, I have a higher probability that u sub will work because they are directly related to each other through derivatives.
Instead of changing like the interval, like the limits at the beginning, could you just keep them the same and then like change
At the
it back
end,
to
go back?
X?
Sure,
Yeah,
you could.
okay.
You could. I'm just, especially if you're not gonna take Calc 3. If you are gonna take Calc 3, you want practice with that, trust me. If you're not, then, that's what I did when I took Calc 2, is I put little parentheses. So like right here, I wouldn't have put these, I would have put 3 with parentheses and 2 with parentheses to remind myself. The parentheses said, Jeff, no, that's not what the theta's doing. That's what X is doing. You got to bring it back to X. Do you see what I mean? That's not a standard thing. If you do it for another teacher, they would say, what the shit is this? But that's just the way I did it as a student, because I hated changing the limits. And then Calc 3 hit me in the face. Hard. It was like, smack, oh shit. Oh, it is. Yes?
Could you do a trivial problem, like without the limits and showing without the use it back to the X?
Oh yeah, sure. Let's do it. Here. Do you see any that look good? Or do you have any in mind? Either way.
When I was on was number 6.
Number 6, this one? Okay, and they're nice here, they tell us what to use, right? Okay. Oh, and they even say the right triangle? Ooh. All right. That right triangle is everything. So let's see. Number 6 says this here. All right, let's pretend like it didn't tell me what to use. You already saw it, so it doesn't matter. By the way, if I just gave you this on a test and I said integrate this, would anybody not use USUB? I mean, would anyone not use TrickSub? Yes. Some of you hopefully would use USUB. You guys see how USUB would work? Derivative of the bottom is roughly x, the top has got x and x squared, but the bottom would be x squared plus 9 equals u, so I could solve for x squared, I could do USUB. I totally could. I don't have to do TrickSub on this. On this problem you do, because it says to. So, remind me, what's a good thing to use for x?
Tangent,
Tangent. What kind of tangent?
3 tangent.
3 tangent. So it'll match up with that dude after I square it, yes? Can you right now draw the triangle? If x equals 3 tangent, what's tangent?
X over 3.
X over 3. Can you draw, go ahead, draw the triangle. Tangent theta equals x over 3, draw the triangle. Basic trick. Sorry. Just thinking of myself, somebody like, basic, you're basic. Math boy. Alright. So tangent theta is x over 3, yes? What side's x? The y side, I love it. And then this side is 3s, because tangent's y over x. And then what would that make this? The hypotenuse.
Square root of x squared.
Or 9 plus x squared, anyway, right? So, it's funny, my colleagues do this an entirely different way. And we had a bit of a discussion about which way is better, and we just realized it doesn't really matter. So, they start with a triangle and they get the sub from it. I get the sub from the form, and then I make the triangle. Okay. Can we stop for a minute? Is everybody cool with everything that just happened up there? The problem said we had to use TrickSub. If it didn't, I would hope that a couple of you guys at least would do USUB, because you always rule out USUB, right? It said use TrickSub, we're like, whatever, so we'll do it. I can immediately draw the triangle because if it's not a definite integral, I'm eventually going to have to take theta back to x, and I'm going to do that through this. Yes?
After you do this example, then you go to USUB. There's no.
Oh, sure, yeah. Okay. We'll verify we get the same answer.
Yeah.
Okay. Can somebody tell me really quickly what would sine theta be? From what we've done here?
X over square root of 9.
Yeah, cool. So whatever the flip trig function shows up, at the end, I can immediately get whatever the hell it is in terms of x from the triangle I just drew. Yeah? Why does a triangle exist? Because I chose the substitution we did, which made the triangle exist. Yes? That's the connection between theta and x. So, how do I rewrite all this business here? What goes on top?
Three
3 cubed is?
cubed, 9, no, 27.
27, and then I got tangent cubed. What's dx? We didn't do it, but what is dx?
Secant squared.
3 secant squared.
Secant squared.
Ooh, that's a really nifty theta. D theta. And then what is square root of 9 plus?
Secant, or 3 tangent.
9 tangent squared, because I'm going to square it 3 tangent, right? How do I know I'm on the right track? Because the coefficients of my radical match. If they didn't match, I could never uncover the identity. If I take a 9 out, square root of 9 out, I'm left with 1 plus tangent squared theta, which is an identity. So if you ever choose something for x, and here you get 9 plus 16, you chose wrong. You chose poorly. So then go back and choose something better.
Can you explain how you put all that stuff together?
So x is 3 tangent, so x cubed is 27 tangent cubed. Dx is 3 secant squared, bam, d theta. X squared is 9 tangent squared theta, yes. So that's all I did. I put this in, cubed it, put it there, bam. I put this there, bam. And I put this and squared it and put it there, bam. That's all I did. So the minute you identify x, you got dx, you got x squared, you got x cubed, you got whatever. Is everything in terms of theta now instead of x? So I'm golden. I can keep going. How do you simplify this?
Take out the constant.
Yeah, well, let's see which constants stay alive. What comes out of here?
27 over 3. Times 3.
I'm just going to collect all the crap on the top, yes? So there'll be 3. Yes, take a square root of 9 out, that's 3. And then I'm left with 1 plus tangent squared, which is 1 plus tangent squared, which is secant squared. Square root of that is secant. Threes cancel. That's why you don't multiply your numbers until you see what's going to cancel, right? Don't make these big ass numbers and then try to. No, just don't multiply them out yet. See what's going to kill each other. If any. What else kills each other? Yeah, one of the secants dies. Now I get 27 integral tangent cubed secant d theta. What are your two options for your trig integral here? Yes?
Or you could take one tangent out.
And put it where? I mean, you could, yes. Okay, just go with it. Is everybody cool with where we are now? You guys, did everybody follow what happens now? So we did a lot of simplification. We got everything in terms of theta. Now you reevaluate. You pretend like this is the problem I gave you, because it is its own problem. It doesn't matter what came before. It doesn't matter that you felt like you already did enough shit. You're not done. It's its own problem. It's a brand new problem. And now how do I do that kind of problem? What are the two things I could use for u sub? I could let u equal tangent. Why is that immediately not good?
Because
What
you
would
don't
it
have
mean?
the derivative.
It would need secant squared. Only got one secant. You guys see that? I need you to not try to memorize everything and just see the logic behind it. What do I got to work with? I got one secant, so you can't be tangent because you only got one secant, and it would need 2 for the when I take the derivative of tangent. What's the other thing I could use instead of u equals tangent? I could use u equal, instead of u equals tangent, I could let u equal secant. And what's the derivative of secant? Secant tangent. Do I have a secant tangent? Yes. In fact, what's left? So this is kind of like what you were saying, but I wasn't sure if you were saying it for the right reasons, Sarah. If I take one of those, that's a 2 now, one of those tangents, that wants u to be secant, yes? If u is secant, I can't immediately get rid of that, but I can rewrite tangent squared as
1 minus, no, 1 secant.
secant squared minus 1. Yes. You're all like, what are you trying to tell me, Jeff? All right, let me stop. So it's not a matter of memorizing shit. You say to yourself, I only have 2 things I could do with this integral. I could let u equal tangent, no good, or u equals secant. Well, what I need if it was u equals secant, I need a secant, and then I got those. And now I got 2 tangent. Okay, beautiful, tangent squared. Having an even power on a trig function is no problem because I can rewrite it with an identity. Yes? So, I rewrite tangent squared as what?
1
I thought we had.
secant
squared
minus
minus
1.
And then secant theta, tangent theta, d theta, and I let u equal secant theta so that my du will be all this mess here. Secant, ba 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 ba. Okay. Ba ba ba. So when I go to rewrite this, what do I put here? U squared. What's all this shit? Du. Is that integral hard? No. What's hard about this is how many levels of substitution have we done? 2. Didn't we do a sub from x to theta? And then we did a sub. How many of these kind of problems can I give you? Not many, because that's taken a while, yes? But I could certainly give you one of them. along with other ones. Don't look so happy about it, Jeff. So, and again, even if I lost you on step 2, please ask me now before I continue leaving you in the dust. The minute I do something that doesn't make sense, bring it up. I guarantee you, you're not the only one it doesn't make sense to. That's why some of us don't ask questions. You're always like, well, everybody else looks like they're getting it. I don't want to say anything. No, screw that shit. Even if everybody else did get it, who cares? You're paying. You're here. You're paying for this shit. Get something out of me. Okay. Yes?
Was the only purpose of the triangle just to help visualize the relations?
At the end, I'm going to take you back to theta stuff, yes? The only way I can then get from theta stuff to x is through the triangle. Because if I get a sine theta in my answer, then from the triangle I can see what that is. Do you see what I'm saying?
Yeah.
So I highly recommend that the minute you make a substitution, you go ahead and have the triangle made and ready. So when you get to the end, you can reference it. Hopefully it'll remind you. So a lot of you guys did the homework and you stopped at blah theta, and I circled the x's in the original problem and drew an arrow. And some of you guys may be like, what's this guy, what's he want from me? Well, if it started with x's, it better freaking end with x's, yeah? Okay. So help me out, what's the integral of u squared minus 1?
1/3 u to the third.
Yeah, 1/3 u cubed minus u plus c. And what's u? Actually, let me do this too. I'm going to distribute the 27. Is that okay? So that's 9. What's u? Secant theta. And what's the integral of, I'm sorry, we already did that. So I'm going to distribute the 27. U is secant theta. So see, this is where some of you guys stopped on this problem. I remember this specific problem. Some of you guys stopped here. Why is that wrong?
It's not sure specs.
Yeah, the problem had to deal with x. So if somebody's like, hey, what's this function of x become? And you give me, what's this integral of x? And you give me theta, that doesn't answer the question. The theta was something we did to help us work with the original weird-ass x function. The answer has to be some x function. So go back to the triangle. What do I need to know? What do I need to know? Secant theta. And what's secant theta?
Square root of 9 plus x squared over 3.
Good. So wherever you see a secant theta, you just throw that shit. Yes? Do you see that? Wherever you see a secant theta, guess what you're going to put there? You're going to put there what it equals. Secant theta is square root of 9 plus x squared over 3. Now this, if you left it like this, I'd be kind of okay with it. But you guys see how there's more stuff you could do? 3 cubed is 27. 9 over 27 is 1/3, yes? This you can write as that to the 3/2 power, yes? 1/2 power to the 3rd power to the 3/2 power. This you can do this, blah, blah, yes? Simple simplification you definitely should do. Now, somebody requested that we do the same problem again, but with u sub. So let me do this simple simplification. Let me do the simplification that I said just a minute ago. All right, that's what I get there. Cube that, simplify that, divide this, okay. Now, let's go back to the beginning. Let me stop for a second, people are copying it down. If I go back to the beginning, I just now have the sound of music in my head. Go back to the very beginning. At the beginning, there was this problem here. How would I start to do u sub? What would you make u equal to? What's the only thing that really makes sense? 9 plus x squared. Isn't that the thing that's stuck? Isn't it stuck twice over? Isn't it stuck on the bottom? And it's stuck inside of a radical. And 98% of the time, what do you let u equal? The piece that's stuck somewhere. Not all the time. 98%. Right? 98% of the time, it works every time. Can somebody tell me right now what x squared is?
U minus
U
9.
minus-
U minus 9. And what's du?
2x.
2x, yes. So do I have everything I need? I'm missing one thing that we don't care about, what we can make happen now easy. What am I missing? A 2. So let me rewrite this. I'm gonna put a 1/2. I'm gonna break up my x like this. Okay, so everything's the same. I actually just did nothing. Well, what's this?
du,
du. And what's this?
u minus 9.
U minus 9. And what's this?
Square root.
Square root.
9.
Now, real quick, I still have some of you guys. Is there, when I'm taking do you guys agree? Derivatives are always easier than the associated integral would be. Do you agree with that statement? There might be some really obscure thing you can go, not in this case, but I mean, again, 99.999% of the time. When I have to do a derivative of a quotient, is that easy? Or is it kind of involved? Isn't there several moving parts to the derivative of a quotient? You guys agree? So if I'm gonna integrate a freaking quotient, that is stupid weird as shit. So you can't just integrate the top and integrate the bottom. That makes no sense. I couldn't even do that with just the derivative. And you guys just told me derivatives are almost always easier. Yes? I need this to make sense. There is no quotient rule for integration. There can't be. Integration is trying to undo weird shit derivatives did. There are some rules for integration, and by parts is like integration's attempt to answer chain rule. Yes? So, you know, it's nowhere near as nice. So I don't know. I still have a few people doing shit like the integral of x squared times 1 over x is 1/3 x cubed times natural log of x plus c. Yes? And no, the problem isn't that. You guys see the problem? Please tell me you see the problem. You can't integrate parts of a multiplication. What would you do? What the hell is x squared times 1 over x? Freaking x. So what do you always do before you try to do calculus to something? Simplify the damn thing. Yes? Okay. Sorry, I'll come back. I'm just seeing this a little too much, this kind of thing. It's going to be very concerned. So what do I do? What did I just say? You simplify it, right?
Mm-hmm.
All right, so how do I simplify that? What's u divided by u to the 1/2? What's a whole u divided by half a u?
Half a u.
Half a u, there you go. And this would be minus 9u to the negative 1/2, is that cool?
Mhm.
And now isn't that nice? It doesn't flow into an integration rule. I'm gonna go a little quick because I don't wanna, I'm taking up all our time with this one thing, but if you do this, it'll be 2/3 u to the 3/2, yes. Minus 9/2 times, this would be u to the 1/2, so I multiply by 2. Is that cool? Plus c. And so I get 1/3. What was u? 9 plus x squared to the 3rd power. I'm sorry, to the 3/2 power. Minus 9 times 9 plus x squared to the 1/2 power plus c. Let's compare. Where'd it go? There it is. Same shit, yes? And I have to tell you, I wasn't keeping an eye on it, so when I went to reach for this, I'm like, please, dear God, tell me it didn't make a mistake. But that's exactly the same shit, isn't it? So who cares which way you do it? Unless I tell you you have to do it a certain way, but I don't do that too often, because I want you, part of what I want you to learn is when is one application better than the other ones, and what do you always try first? Because it's always easier. I don't know if you guys agree with me that that was a lot easier than what we just did with the double substitution shit and the inverse triangle, and that was a lot easier, yeah? Yeah, I would do that shit. Is that right? Now, if I go back to the original problem and I make this squared, can I do what we just did? What do I have to do then?
You have to do tricks up.
Then could potentially do by parts, but do you want to do by parts?
No.
All right, do you see how there's a hierarchy to what's generally more difficult? U sub is always better. Trick sub very often is better than by parts, but sometimes not. Anyway, all right. If I ask you to integrate something, you definitely see if U sub will work first before you do anything. Yes? Okay. All right, guys. Anybody want to focus on anything else? Does anyone need to see anything I just did again? Okay. I don't know if I took it away from you too quickly. Yes.
Another trick sub that's kind of weird.
Okay. Yeah, nobody's asking anything, so it's your floor. What you got?
It's a definite integral between 0 and a,
Oh yeah.
and that's 5 times x squared times the square root of a squared minus x squared.
Just like that?
Yeah.
Okay, good. One level that you have got to understand you need to get past is the fact there's an A. We have to acknowledge it and not let it bother us worth shit. Whatever A is, I would always do the same thing that we have to do now, yeah? What we're about to do is more powerful because what we're about to do will work no matter what A is. So, understanding A is just a number. What trig sub will I want to use? Because real quick, can I rule out U sub? Can anyone tell me what would have to be out here for U sub to work? The most direct thing would be X, yes? If it was that, U sub would work. Or, does anybody understand what else could be out here? X cubed. Because then the X squared piece would be what I would solve for U, and then blah, blah, blah. Okay. But that's X squared. Damn it, so we have to do trig sub. Or by parts.
Nope.
Good. Just like to throw it out there because it's a valid way. So can somebody help me out? What would I use for the trig sub?
A sine theta.
Good. A to match up with that guy. Sine theta because this is constant minus function squared. That's like 1 minus sine squared. I like it. So what's dx? A cosine theta. D theta. And what is x squared? You can always do this if you want to also. You can build everything you need. What's x squared?
A squared sine.
Yeah, okay. So now you just throw this shit in there, yeah? Now real quick, before I go any further, I'm always gonna do this because of what I said earlier. Part of what I'm supposed to do as a Calc 2 teacher is to get you ready for Calc 3, which I also am teaching, so some of you guys might take my Calc 3 someday, so I want you to be ready. I want to change my limits, yes? You don't have to, but I recommend it. So when x is 0, what's theta? Sine of what makes 0? 0. When x is a, what's theta? I need sine theta to be a equals a times what? What do I multiply by a to get a? What do I multiply a to get a? 1. So what makes sine theta 1? What makes sine theta equal to 1? Pi over 2. So when x is 0, a is 0. When x is a, theta is pi over 2. And this will be 5x squared square root of a squared minus x squared. And of course I left myself in the room. Dx is a cosine theta. D theta. Poor little guy. Don't forget, this is your DX. I left myself no room. And now you just gotta simplify stuff, yeah? This you can simplify 2 times over. Take out a, and you should go, yes, Jeff. Take out a. 1 minus sine squared is cosine squared squared is cosine. So all this becomes a cosine. Times another a cosine makes a squared cosine squared. Times this business, yeah? Let me stop for a minute, you guys. Now it's just simplification. At least for the moment. So I get 5 a cosine theta times a cosine theta is a squared cosine theta times a squared is a to the 4th sine squared cosine squared. Now you have a choice to integrate this. What really, can anyone tell me what sucks about the powers on the sine and the cosine? They're both even, which means neither one has an extra to give. Yes?
Which means you're gonna have to use
You
the
do have a choice though. What is sine theta cosine? What's 2 sine theta cosine theta?
sine 2.
Sine 2 theta. So what's sine theta cosine theta? 1/2 sine 2 theta. Yes? So you could replace that with 1/2 sine 2 theta all squared. But now it's your choice. I could take the 5a4 out, yes, it's just a constant. If you want to do brute force, you can rewrite sine squared as what? What's the identity for sine squared to have no square anymore?
1/2 times 1 minus cosine 2 theta,
Good?
and then that would be squared.
Oops, no. Sine squared is this.
Oh, right.
Cosine squared is
1/2 1 plus cosine 2 theta.
yes? And then, like the 1/4 you can take out, and you can distribute this. Do you see something kind of nice about these two? Aren't they kind of like difference of squares kind of stuff? Okay. So it's going to be a few steps after this. But does that get you going? Is that okay? I mean, now it's just, all right, if nobody has any more questions, we could do the rest of this if you want to. Right?
I have a couple.
Huh? You have a couple?
I have
But just to show the next
at
step.
least 2. But
Do you see how I can take a 1/4 out? Do you see how I can distribute this business? Is that cool? Just a difference of squares kind of thing, yes? Now I have a squared trig function again. Now, notice it is 1 minus cosine squared 2 theta, so I could make it, what's 1 minus cosine squared? Sine squared. So I could do this.
Sine squared times cosine.
Oops. But I still have a squared sine, yes? So then I have to do this again. But now my angle is 2 theta, so what's going to end up here is going to be 4 theta. Okay. So you should have hit a few of those kind of problems in that section where you have a couple levels of squared to take care of. Try to make sure that happens because it happens. Okay, I'm going to let you guys do the rest of that one. You basically just have to do exactly what we just did. You should end up with 1/2 1 minus cosine 4 theta, and that you can integrate. Pretty straightforward, yeah. Now, something I didn't do at the beginning that I didn't need to was the inverse trig, I mean the inverse triangle thing. Because do I have to bring it back to x since I changed my limits? No. So that's kind of like where young Jeff was. I didn't like changing limits. But then when I started doing some of these problems, I was like, maybe there is something to this. Because if I change the limits, I don't have to go back to x. I can just start throwing shit in. So it's a bit of a trade-off. Yeah? Okay. So Sarah, you said you had some other questions?
yes.
Which?
They're on the practice test.
Yeah.
I guess the first one would be D. You said that you were gonna talk about it, I think, this class, cause you
Oh,
didn't get
this
to
one.
it.
Okay, alright. Yeah, I did it on the, answer key, because it's lower. Did anyone try 2D out of curiosity? So let me ask you this. Alright, listen. Hopefully it makes sense that, based on what I said, I put this on the practice test as a bit of a challenge. I'm not gonna give you a problem like this on the test. Not like this. This one is very tricky. You all agree this does not really fall into a pattern of anything else we've done. So why did I put it on there? Because practice test is not due. You don't have to do any of it. So I can shit I want. No. I wanted it to be here for discussion, and I wanted to see if anybody would try anything. Now listen, if you had to, what method do you hope would work? USUB. Yes? So the way to do a problem that you have no idea what to do is to be optimistic. Okay, USUB is the easiest out of all the weird shit. I can't just integrate this directly because I have no idea whose derivative is this. Yeah? So I gotta use a method. I'm gonna try USUB. What would you let U equal? What would make, in general, what makes most sense to let U equal in this situation?
Cube
By the way,
root
it's
of
a cube
X
root, by the way.
minus 1.
Yes, I'm gonna let U equal the bottom. Let me write it like this because it's better. Let me write it like this. So what's du?
One third
Okay.
X to the negative.
1/3 x to the
Two-third.
negative 2/3 x to the okay. Right, that's where you guys should jump in. That's some easy shit. Now here's what's trippy. I know the bottom would be U. Does it look like I have what I need? I do. Whatever, Jeff, just do it. Okay. You guys, I don't know if you're ready. Don't I want an extra negative 2/3 on top?
Mm-hmm.
There's two ways to do this. Let me think, which way do I want to do it? I'm going to do it this way because it's the more interesting one. I'm going to take an x to the negative 2/3 out of the top. I just am. And at the same time, I could put a 3, so I could put a 1/3. So do I see my du? Now, the thing you guys have to start to understand is, of course I can do this shit. Of course I can. If you say I can't, then you are saying there is nothing I can multiply this by to make this. Ignore the 1/3 for a second because that's there just because I put the 3, yes? What would be here to make this times this x to the 1/3? X. A full x minus 2/3 of an x is 1/3 of an x, yes? So this would be x. Now, if I take something out, I divide it out, yes? So let me see if you guys are cool with this. This would be x to the 2/3. Divide x to the negative 2/3. When I divide, I multiply by the reciprocal, blah, blah. Or you can say negative 2 plus 2 is 0, so I get my 1 back, yes? So what I just wrote is exactly the same as the top here. I did nothing. Good job, John. Now, real quick. If u is x to the 1/3 minus 1, what is x to the 1/3?
U plus
U plus 1. What is x to the 2/3? You can do it. Squared, yes. And what's x? What do I have to do to get x? Cube. Now, do I have a substitution for everything that was x? Do I have a substitution in terms of u? That is all you need for u sub to work. That's why u sub works much more often than you guys realize. In fact, just to show you, I'm just a stupid human. It works in more places than I know. I can't possibly know everywhere that u sub can work. Because you can manipulate shit like this so you go crazy. I don't have all this shit memorized. Are you kidding me? when I see a problem like that, if I saw that in the wild, I would freak out at first, a little bit. But then I would go down the rabbit hole of, well, I hope U sub works. U equals the bottom makes the most sense. Let's see where that takes me, yes? Now, obviously, I would not give you a problem like this on the test fresh, because you ain't got time to play with that shit, yes? So a test is not the place to play with shit. Homework is the place to play with shit. Okay. So I'm not gonna do this kind of thing to you on a test. I won't, unless I do it a bonus problem. In which case I can do whatever the hell I want to. But let's see. So now I get 3 integral. What's this? du. What's this?
U plus 1 cubed
U plus 1 cubed.
plus U plus 1 squared.
Good. All over
U.
U. Good. Could you cube this? Yes. Could you square that? Yes. Could you divide all the shit you get by U? Yes. It's just a polynomial. Who cares? I'm not going to do the rest because I don't want to. I did it on the answer key, I think. But is that, I mean, all right, real quick. I want to do it real quick because you asked about it. It's on the answer key. It's a little side note, but I want to show you the flexibility there is in U sub. That is probably the trippiest U sub problem you have seen to date, I would guess. But the more that shit you see, the more you realize what to look for, and you can do more shit with U sub. And why is that good? Because U sub is relatively easy. Okay. Yeah, so if you want to see the rest of it, here, let me go ahead and give it the key. Why not? It's 2 pages, yes? So you should end up with 2 pages. Oh, you didn't take one for yourself, okay. So it's selfless. Waste one. So in one semester, a student asked me if I hand wrote every one of these. One page. 2. Okay. 2D, you can see here. We got to this point, yes? I kind of skipped over. I don't know if you guys know Pascal's triangle. If not,
Yeah,
you're
a little
fine.
bit.
But it's just a quick way to do stuff like this. Blah, blah, blah. Yakety schmackety. Provide, integrate, blah, blah, blah. Yes.
I was looking at 2E. I did 2E, but I got something different.
Did you do it a different way than I did?
No.
Okay. Let's see.
I
Ask
got
Jeff.
I
I-
got natural log
Where's
of
2E?
cosine x, not natural log secant x plus tangent x.
Where's my 2E? Oh, there it is. Okay.
It's on the second page.
That makes sense. So let's see if I did all this right. U is x, du, dv is that, so v is this. uv minus the integral of v du.
That's what I
Oh.
got for that.
Sure. And?
I got, that's what I got once I did the by parts.
Yeah.
But when I got to the answer, I got x secant x minus the natural log cosine plus c.
Oh, no. Secant is 1 over cosine. So, let me see. Is the integral of 1 over x squared, is that natural log of x squared?
No.
Of course not. The only function that becomes natural log of x is 1 over x. So 1 over cosine x is not natural log of cosine x. It cannot be. Now, if on the test, I'm not going to make you memorize secant. We did talk about the integral of secant. But if I gave you a problem that required you to know the integral of secant x, I would give you this. I don't know if you guys remember, is where you had to multiply top and bottom by secant x plus tangent x out of nowhere.
Oh.
Yeah, so I would give that to you. But I was just hoping maybe somebody remember from the notes. We did talk about that. So if I gave you like either integral of secant x or integral of cosecant x, I would give you what they are, because that's a little tricky side note. So, for some of you guys, you've never had me before, and you're like, how can this guy write so horribly? But you'll get over it. The other thing is, when you get in one of my answer keys, if you haven't tried the practice test, don't do this. Yep. I would have done that, right? Because then you're building false confidence. So don't even look at this if you didn't try the practice test. Yeah? Don't even look at it. Don't. It does you no good. It will give you false confidence because it's easy as shit to agree with me. By the way, I make mistakes. I'm averaging about a 97 on my answer keys. So if you see something that looks like it could be off, I'm human. I could have made a mistake. I don't like using test banks. Test banks are stuff teachers use that's pre-packaged tests and pre-packaged answers. I hate that shit. Which opens me up to making a stupid little mistake sometimes. So I'm okay with that. Yes?
2A, I think, is a little bit off the answer.
Okay.
The very end is.
Shoot, lumps, no.
Negative 1 plus 1, it shouldn't be plus 1/3.
Where are we at? Here?
2A, the one right above it.
Oh, this is B. Okay. Yeah, I got caught off a little bit, darn it. 2A.
At the very end, it shouldn't it be 1/3?
Oh, yeah. Okay, so let's see what this should be. I really made this easier than it should be. So it should be 0 makes 0, and then it's minus 1/5 plus 1/3. And here's a really cool way. Okay, I'm going to pretend like I did it on purpose. I did. This is one place where cross multiplication can be used in a very creative way. This would be negative 3 plus 5 is negative 2 over 15. Is that what you got?
Yeah.
Negative 2 over 15, yeah. So everybody see that, 2A? I just left off my 3. Okay. So that would be about a 99. Is that okay? Or, you know,
Positive.
huh?
It's positive.
It should be positive. I'll just keep making mistakes. I did that on purpose and then I forgot I did that. So negative 3 plus 5 is positive 2. Even better. Okay. I don't know if you guys see what I mean by cross multiplying. You can't officially cross multiply here, but they both need each other. So then 3, so negative 3 plus 5 is 2 over the product, 15. That's a cool little shortcut for adding fractions. Especially when the bottoms are what's known as relatively prime. Is 9 a prime number? Is 9 a prime number? No, because it's more than just 1 in itself, yes. Is 9 relatively prime with 4? Yes. Relatively prime means they don't share any factors in common. So if I had 1/9 plus 1/4, what's the LCD? 9 times 4. Yeah, so when the bottoms are relatively prime, the LCD is just their product. Then cross multiplying the way I just did it makes that easy and quick. Okay, enough. If you use properties of logs to rewrite 2b, that's beautiful. Little tears for you, but you don't have to. You can leave it like that. I noticed some of you guys like to rewrite it using properties of logs. And again, little tears for you. That's fantastic. Yeah.
Can we do 2f? Like with all the steps?
Oh, what did I skip stuff? So what I did? Oh, because I did talk about this a little bit in the class last time, didn't I? So, cosine 2x, I can write that as cosine squared x minus sine squared x.
Mhm.
One of the many identities you guys know. And I'm going to assume you know it. And I'm going to put a problem on the test that could use that one or any of the other ones. Because I'm an asshole. Can you factor this? Can you factor cosine squared x minus sine squared x? Isn't that a difference of squares? Yeah? So then that would become cosine x minus sine x, cosine x plus sine x, yes? So if I put this here, don't I get 8 of these? This is another example of a problem. I probably wouldn't put exactly this kind of problem on there because you just have to kind of see it. You just have to see this leads you to something good. If I replace cosine 2x with that specific one, I could break it up. Part of it goes with the other ones and makes 8 of them, and part of it goes with dx and becomes the du. If I just gave you this, what would you think you have to let u equal? What makes the most sense to let u equal? What's stuck inside something?
Cosine x.
Plus sine x, yes? So what's the derivative of cosine x plus sine x? Negative sine x plus cosine x, which is what this shit is. So isn't this du? And isn't this u? And you have u to the 8th, and that's easy. So, when you are in doubt, I'm not saying this is going to work every damn time. Definitely not. But if I'm looking at an interval, I'm like, I don't know what the hell to do. Think, if it was u sub, what would I let u equal? And then just see what that leads to, and see it might not be the way to do it, but this is what I mean by rule out u sub. What would u sub lead you to? If it's nothing good, then you go, shit, maybe it's trig sub, maybe it's something else. You guys kind of see what I'm saying? In this case, it does work. Okay. Yeah, so I'm going to give you this, yes? So all you really need to do, in fact, I didn't put this on the answer key, did I? I think I meant to do this with you, so let's do this one. Do I have any more paper? I should have more somewhere. Aha. Here we go. Oh, yeah, sorry. So we got the form of it. We know the function we're dealing with. I think I pointed out to you last time that you might think by parts, but that goes nowhere. This is an interval you cannot do by hand. The best we can do is brute force, get a numerical estimate for it. So I want to use 6 trapezoids. Show how wide is each one going to be.
4 minus
Yep.
0 over 6
So each one's going to be 2/3 wide.
times 1/2. Well, yeah, that's how
Don't worry
it
about
would
that.
be.
Delta x is 2/3. Yes?
Mhm.
Now, unless I ask you to, don't graph the damn thing. All I need is where the trapezoids are going to start and end. Yes? So where am I going to start? What's the very first trapezoid start at? 0. Where does it end? 2/3. And that's where the next one starts, yeah? And then the next one ends 4/3. 6/3, which is 2. And then the next one ends 6/3 plus 2/3 is 8/3. And then the next one ends at 10/3. And then 4. And then the next one ends at 14/3. Yes? And then 16/3. Did I go too far? I should have stopped here. Okay. Get out of here. We don't need you. So I want to stop at 4, yes? And let's check. This would be 1 trapezoid, 2, 3, 4, 5, 6 trapezoids. So, I mean, this is all shit you could do very quickly. Just make sure. Do you see? I don't need the picture. I don't need the graph. When you did Riemann sums, we did the graph so visually you can see what was going on. I don't really need them. I know this is more of a analytical thing, not a geometric thing. It's based on geometry, but I don't need it. Don't try to graph that crazy ass thing. I just need to know where my trapezoids live. So now I know what my inputs have to be. Yes? You guys good? So now I just have to do, like Sarah was saying, this is 2/3, but then out front I put 2/3 divided by 2, which is 2/3 divided by 2, 1/3. And then I want to do f of 0 plus 2 f of 2/3. Do you see? Can you see? Okay. Plus 2 f of 4/3 plus blah 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 2 f of 10/3 plus 2, not 2 anymore. F of 4 at the end, yes? So the first one and the last one doesn't get a 2 because they are not in 2 trapezoids. Everything in the middle is a member of 2 trapezoids. That's why everything in the middle is double. You have to know everything I just said to be able to do this problem. No, but it's good to know why the shit there's 2's. So now you just throw all this shit in there. Yeah? This is just brute force computation. You just have to set it up, get to this point, throw shit in, do it. Yeah? Is that all right? I almost don't care at this point. I mean, it's just, you could use a table if you want to, right? You could put the function into y1, you could look at the table and get the outputs, you can even set it so that the table width is 2/3. I showed you how to do that. Get all the outputs, throw them down there. Maybe. And then, I actually asked you to do this. I might not ask you to do this, but on the test, if I ask you to do a trapezoidal rule or something, don't you want to know how to get the exact right answer? You guys know how to do that in calculator, yes? I think I showed you. Did I show you? Does everyone know how to make the calculator do an interval?
Yes.
All right, if you don't, you had a chance to speak up. Too bad. Do you have to know how to do it? No. I'm not going to ask you to do it, but here I did, just because I just wanted to see if anybody didn't know how. But anytime you have to do a definite interval, you can check your answer with the calculator. Not this one, but proper intervals. It's got to be legit. Okay. And then, I mean, do you see how if I make you do this back to back, you've already got like the function values you need for Simpson's rule? You see what I mean? You've already got everything set up for Simpson's rule. You just have to, some of them have 4s now though, so, but still, you already have all the function values from the trapezoidal rule you had to do, yes? Maybe? Okay. You guys look like you barely tolerate me, but we'll be okay. Quick little story. One semester I was teaching, and somebody was sitting like right here. The whole semester she had this look on her face like, you suck. Final. She turns her final and she says, "Thank you, Mr. Waller. This was a great class." And I'm like, I thought you hated my guts. So, I try not to read any faces for anything. Anything else you guys see on here that's, need some looking at, or anything look wrong on the answer key?
2H.
2H?
Just like to get started with it.
Oh, okay.
'Cause
Can I cancel an X out?
no, because of the root.
There's so many reasons why not. So many reasons why not, so no. This isn't a classic look of this, but what do you guys think I have to use here? Trig sub.
Okay.
Because you see the x squared minus 1, that form. So that doesn't have to be in a radical, it doesn't have to be on the bottom, it just has to have that form in it. Somewhere in trig sub might work. One of those forms, x squared plus 1, x squared minus 1, 1 minus x squared. Trig sub might work on that. Okay. Which way? I must have done trig sub, yeah? I don't think past Jeff saw anything too different. Yeah, I did trig sub. Look at me go. Look at me go. That would be a beautiful candidate to check your answer. So like, if you do this and you get this, put this in the calculator, get your decimal, put this in the calculator, make it integrate from 1 to 2, and compare. This problem, you should get exactly the same thing the calculator gets. The trapezoidal Simpson's rule, it should be close because, of course, those are estimates. Yeah. So if you don't get exactly perfect on those, you're fine. If you get 40 and it says 11s, should be 40, maybe 39.7 or something, yeah? Especially for Simpson's rule. Yes?
Have we ever talked about anything like number 3?
If not, that would be really mean. Yeah, yeah. I say that because you were in my 180, so I can say that to you. But number 3 is an idea from 180.
Really?
Yeah, totally. How do you find the average value of a function? You integrate the function and you divide what you get by d minus a. So I just integrate that function, but divide what I get by 1 over 13 minus 10. Now, real quick, just because, I don't see anybody with questions, so I'm going to show you this. This is such a cool flippant idea. I have a function, blah, a to b, yes? If I integrate it from a to b, I'll get the area here, yes? Is that cool? Okay, if I divide what I get by the length, I'll figure out the height of the rectangle that has the same area. And that would be the average value, the average height the function attains. That's all it is. That's all that stupid thing is. If I divide by the width of what I get, I'll get the height of the associated rectangle with the same area. That would be the average height of my function. That's it. That's all that shit is. Now, I probably wouldn't give you a problem like that on the actual test. Just because I don't know what happened to you in 180. Maybe your teacher skipped that section, right? Or maybe you took it 7 years ago and you're like, I know I did something. But I wanted to put it on here for this reason, just to have a discussion and to remember, this is another one of me just saying all the shit we did in 180, you could do the same ideas, but now I can do it with more functions. Like when I try to make you guys do shells, cylindrical shells. And I love what was I thinking?
I don't know. I don't know.
Number 4 is another example of that, right? Did we talk about number 4 last time?
Yeah, we did.
You have to find when they match, and then you have to figure out what's on top. But it's still a 180. It's a very much a 180 idea. But that's an integral we didn't talk about how to do in 180. We could have integrated cosine squared, but we waited till now to talk about it. Yep. Yes.
It's not on the practice test, it's a homework question.
Sure. Yeah. What you got?
It's a definite integral between 0 and 0.6, and it's x squared over, over the square root of 9 minus 25 x squared.
Ooh, yeah. Yummy, yummy. Damn yet. Okay. So, x is not 3 sine theta, yes? Because the 25 is in our way, so. Don't you wish the 25 wasn't there, number one? And number two, number 0. Do you all agree this is trig sub?
Yep.
Yeah.
The top would have to be x or x cubed for it to be u sub, and it's neither, so it's trig sub. Don't I wish the 25 wasn't there? So the first thing I want to do is let x equal something that after I square it, the 25 dies.
So divide by
So don't I want a 5 on the bottom of it? You see that? Wouldn't that make the 25 go away?
Oh, yeah, because you had squared.
You with me?
Yep.
Whatever the shit I put on the rest of x, what's x squared? Stuff over 25, yes? Wouldn't that kill the 25? Now, the 25's gonna be gone. Now what do I want the top to be?
3.
3, because now I want it to match with the 9. Maybe?
That.
Okay. See, that's the beautiful thing about a lot of mathematics is, what do you not like there? Okay, and this is not a life lesson. Not a life lesson. What do I not like there? The 25. All right, let me kill it. They're good. I mean, they're like VCs. The existence is pain, so they want to die. So 3/5, and then what's the trig function, of course? Sine theta, yes. Good, okay. That's what I prefer. To be honest, I could teach this weird shit. You ready? I could teach this weird shit. And say that I want x to be a over b. And see how that's dumb? That's just like, oh, there's more stuff to memorize. Why is it that? Because he said so. No, doesn't it make more sense for me to say, I'll kill the 25 over 5. Match the 9, 3. You can see how I put that together. It's not memorization, it's just what I need to have happen. Yes? Okay. It's better to not memorize more than you absolutely need to. Because ain't none of us got enough room for all the math you might need. I got all of my math memorized, that's for damn sure. Is that okay? I don't know if that was a major stumbling block. Because now you just do dx and x squared, yeah. 0.6 kind of sucks, but watch. If x is what is 3/5? 3 divided by 5. 0.6. So if 0.6 equals 0.6 sine theta, then I want sine theta to be 1, therefore theta would be pi over 2. So that when you do the substitution, it'll be nice. So the 0.6 looks evil, they're actually being nice. Okay, maybe. By the way, I do that very often. You look at my limits and you're like, God, this guy's an asshole. But if you do the u sub, you're like, oh, okay. He's still an asshole, but not because of this. By the way, just to put this out here, one option is to leave early if we get all the questions answered you guys have. But what I've noticed is sometimes what happens is people don't want to leave, so they hang out just in case somebody asks a question. Nobody asks a question. So, if you have more questions, ask away. But I'm not going to force us to be here longer than we need. Yeah. Yes, what's up? What you got?
Oh, I was just saying I'm done with questions.
Oh, you're done with questions? Okay, I thought you said I have questions.
Can you do it improperly?
Improper. Do you want something different than what's on here?
Yes.
Okay. So what type? There's 2 types of improper integral, yes? What's one type?
When there's like an infinity somewhere within the integral. or
Within the limits.
Limit.
Or the limits are finite, but at least one of them makes the inside function go to infinity.
Go to infinity.
Or the bottom 0, which means the function goes to infinity. Yes? So there's either infinity explicitly on the limits, or there's an infinity implicitly if I plug a limit in. Okay. Let's just do one like this. Oh shit, if I try to make one up, it's never going to do what I want it to do. Unless I have time to think about it. So, let's do, yeah, let's do that one. Let's see, make this a 1. Oh, wait a minute. Ooh, all right. Let me see what you guys think about this. This I like. Ooh, look at that. That's yummy. Okay, I'm aware that's creepy when they say that. I don't care. So what do you guys see in there? Does anyone see something in there? What do we all do first? Besides simplify? You simplify if you can. You can't do shit simplification. You look for use of. Now, some of you might say, well, I like u equal x squared. You see that's not going to go anywhere. What other piece is stuck somewhere? Negative 1 over x. And what's the derivative of negative 1 over x?
Negative natural log.
No, you're integrating. What's the derivative?
Oh.
Negative 1 over x.
Almost.
Negative.
But remember, this is negative x to the negative 1, so is that in there?
Almost.
No, it's exactly in there. Isn't this 1 over x squared? Isn't that du? Yes?
Okay, I see.
If you want a 1 up top, you always have a freaking 1 up top, because there's always a 1 there, yes? So if I use this u sub, now actually, what's the very first thing I should do? Before I do anything else, I've already done too much. What's the very first thing I should have done?
Change
Yes.
it to
In all honesty, if I was going to do this problem, I wouldn't do that shit. But you guys have to, because otherwise you do weird shit. Now I can rewrite this now. Again, it's a general option for you. You don't necessarily have to change the limits, but I do kind of want to push you in that direction, so I'm always going to do that when I'm showing you a problem. So if I look back at our substitution, when x is 1, u is negative 1, and when x is t, u is negative 1 over t. Is that cool? So this will become the limit. T goes to infinity. Integral negative 1 to negative 1 over t. E to the u du. Okay, I got there. There is something creative you could do right here. If t goes to infinity, what is 1 over t to?
0.
Goes to 0, yeah? I'm not going to do this, but I just want to show you. I can make this the limit as s goes to 0 and replace this with negative s. Because effectively it's the same relationship. I'm not going to. We'll leave it as is. Just in case you kind of see what I said, that's an option. What's the integral here? Yeah. And then I got to plug in negative 1 and negative 1 over t, yes? So I get the limit. When t goes to infinity, e to the negative 1 over t, right? Minus e to the negative 1. Is that cool? Now what did we just say? As t goes to infinity, what does 1 over t do?
Go to 0.
So what's e to the 0? 1. So I get 1 minus e to the negative 1, or 1 minus 1 over e, and then you can make an LCD if you want to, but I'm not going to. So the very first thing you should do when you see an infinity in your limits, rewrite it, and then just forget about the limit. Forget about it. T, you've seen integrals with letters in it. T is just a letter, so you integrate like you normally would. What method would you have to use? Any. Right? The infinity being there is a separate thing. The integral I'm doing could be anything. Trig sub could be, U sub could be, by parts could be, whatever. And that is so exciting. Whew. Yes?
For like, how do you know whether it's convergent or divergent?
Oh, was this convergent?
Yes.
How do I know?
Because it actually
didn't go
goes
to-
to a number.
Yeah, it's a finite number. It didn't go to
It
infinity.
didn't go to any type of number.
Yeah, so if I integrate and have the limit as t goes to infinity of e to the t, what does e to the t do as t goes to infinity? Goes to infinity. That would be divergent. It doesn't converge to a finite number. It just grows forever. So convergent means it doesn't grow without limit. Divergent means it does. And it could be like going to negative infinity, some kind of without bound, either way.
You guys semi with them?
Okay. This idea is gonna come back in a huge way in chapter 11. I think I already talked about that a little bit. Now we just stare at each other. So, I want you all to know, I will stay here as long as you need me to, but holy shit, I would be so cool if we didn't stay. At the same time, if you have questions, I'm here. That's my job. But I'm not gonna take it bad if you guys leave, that's fine. You guys understand what I'm saying? I really want you to understand what I'm saying. I'm here for you. You got questions? I'm gonna stay. Nobody has questions? We shouldn't stay. Yeah, go ahead.
Just how to like, if I'm like setting this up, right, would I just, like,
Oh, no. So,
yeah,
what you wanna do is make it look like, if it was this, then I can see a trick sleeve. So if you kind of wanna do a couple things, you kind of wanna take the 3, the factor of minus,
so you don't wanna factor that.
yeah, I need to keep the square, so I can make that part look like this, and this will just collect. So I'm trying to go in this direction, because then if I make it look like this figure would be x minus 1 equals 2 secant theta.
Okay,
You see that?
yeah,
Okay. That is not obvious, but then there are a couple examples.
Stuck on part E. I think I just got my parts correct.
Where are we at? Okay.
It's okay.
Glasses.